Welcome back to Techonomics from Cyclotron Road. In this video, we'll show you how to build a simple manufacturing cost model. Unlike our previous model, which was based solely on a bill of materials, this model will include more detail, like the cost of labor, energy, and equipment. We'll also be estimating the yield for each manufacturing step. So in the last video, we were trying to figure out a cost-effective design for a high-performance frisbee that we've developed. Using our bill of materials model, it looked like we could hit our cost target if we used a particular polymer called superspin. Our plan was to move forward with hiring a contract manufacturer, but as it turned out, we couldn't find one that was willing to do the final ring winding step for us. So instead, we decided to see if it would make financial sense to buy the winding machine and do it ourselves. Our distribution partner, Disc Sports, will pay us $12 per frisbee, and we want to make at least a 20% profit. Our process is going to have 3 steps: winding, finishing, and packaging. Including a process diagram like this with your model can make it a lot easier to follow. Disc Sports will order 50,000 frisbees a year, but we need to start with more to account for any that are defective. Let's do this by estimating our yield at each process step. When we multiply the yields of the individual process steps together, we can see that we get about 88 finished frisbees for every 100 frisbee cores that we purchase. Now let's lay out the material input costs for each process step. We think our mini factory is going to require 2 full-time operators. This operator cost includes their salary, plus an extra factor for benefits and taxes. We're going to estimate energy costs by multiplying the average equipment power by the cost of electricity. We're going to estimate things like building costs, administrative labor, and insurance based on factory floor space, rolling them into one category called factory costs. Yearly maintenance costs for equipment are typically between 1 and 10% of the installed equipment cost. We'll use 5% as a starting point. Rules of thumb like this are available in many engineering textbooks. You know, it might feel weird to be guessing at user input values like this, but don't worry. Building a model does more than just give us answers. It also draws our attention to important questions. Once we've completed the model based on our best initial guesses, we can go back and refine the input values based on literature, R&D, and expert advice. So we also need a way to allocate our equipment costs to each frisbee. So let's divide those costs by the number of frisbees each piece of equipment can produce over its nominal lifetime. This is what we call depreciation. Alright, so summing up all the costs for each step will give us an all-in cost for the frisbee. Before we start analyzing the results though, let's reorganize this page a bit. I'm going to extract the user input rows and group them near the top of the page. And then I'm going to organize the calculations lower down. This gives us a dashboard at the top of the page with user input and important results, and a separate section dedicated to calculations down below. This is a really useful way to organize your spreadsheets. Well, it looks like we're coming in over budget again, and the superpolymer is still a driving factor. We would need to reduce the polymer cost to $8.15 per kilogram to hit that 20% margin we're looking for. This might be a good time to reach out to the polymer manufacturer Plastico to see if they have any suggestions. You can download this video to use as a template from the Techonomics website. You'll also find other videos and resources there. See you next time.